Thank you. So I've done this presentation a few times, so I'm quite excited about doing it tonight because I've done it previously to data teams. And really this is a talk about data, but to product teams. So I'm quite interested, do we have anyone who would class themselves as a data engineer or anyone who's working in a data team? Okay, I know Pedro is. How about people who are working in product teams, whether that's as a product manager, product designer, product engineer, software engineers? Okay, cool. So some of those people who are working closely with the data team. Okay, that's interesting. Cool. And would you say consider yourself a data-driven business?
I think we'd like to describe ourselves as such. But
interesting.
Lots of people use that term without really fully understanding what it means.
Cool. You're going to be really useful in this presentation. So I'm hoping that you maybe recognise. Am I going the wrong way? Is it that one, Alex? If not, I can just spacebar. The laser's working, if that helps.
Okay. It should be to the right.
Maybe I just need to click on.
There you go.
Oh, that was me.
Oh, okay. Professional.
If someone wouldn't mind hitting the spacebar every now and again, that'd be great.
Sorry,
So, no worries. So this is something that I'm quite familiar with. You have the product team. They've been working on something for a few months. They're like, we've smashed this. We've nailed it. The customers are going to love it. It goes out. Everyone's really excited. And someone in the team might be thinking, did we ever finish the tracking? Would you mind doing the next slide? Just watch it there, Alex. Thank you. And then 2 weeks later, they go to try and find the results of their feature, thank you, see whether it's working. They sit down with the data team and they say, well, there's 10 million events called replace me and nothing else. And you can't get the results that you were hoping to get. Does this, I can see a few people chuckling, nodding, so I've definitely been in this situation. And then this is creating, this kind of interaction is creating a bit of a divide between your software engineering function or your product engineering function and your data team, where the product team are thinking, okay, this is the point that the data team go into Tag Manager and start dropping JavaScript on the page and breaking stuff. And the data team are thinking they're going to roll it out anyway, so it doesn't really matter whether the data's there or not. Does this sound familiar? So this is the problem that I'm really interested in solving, and something that we've been working on at Snowplow. So my name's Steve. I'm head of engineering at Snowplow Analytics. I've been there for just under a year now. And I've got a confession to make, which is I'm definitely one of those product people who've got a long history behind me of pissing off data teams. In fact, Pedro works on the data team at Holiday Extras, where I spent a couple of years annoying data teams. So I'm very familiar with that scenario, normally because I've been in the product team, too excited about getting the feature out and not thinking enough about how I'm going to measure it. So I'm here today to tell you that tracking is as important as the feature that you're shipping, so you need to test it. So of the product engineers or software engineers in the room, I imagine you're already investing quite heavily in automated testing and making sure that the function of your application is functioning as you expect it to. It's really important that we pull the testing strategy into that as well. So at Snowplow, we do have a focus on data quality. So we work with our customers to produce schemed events. So this is making sure that the event that you're generating matches some kind of schema so that you can assert that it's valid. And if you can assert that it's valid, when the data team come to work with it, they know that they're working with a valid data set. Part of that is because anything that isn't valid, anything that doesn't match the schema, we filter that away to be recovered, to be worked on until it becomes valid and then pushed back through the pipeline. So there are things that are in our data pipeline that I left out. Sorry, Snowplow builds data pipelines. We have an open source data pipeline that we then provide as a service. We install it into our customers' own clouds. So yeah, schemas and bad rows are 2 cornerstones of the pipeline and of our product offering. We also offer QA pipelines. So we have test pipelines that you can run against. So you can run your automated tests, or you can play around with your new feature that you've built. Then you can go to the QA pipeline and see whether you captured the data that you thought you were going to capture, and to make sure that that data is valid. But that last step isn't automated. And that means that it tends to happen right at the very end of the project, normally a couple of days before you're due to go live. Someone thinks, oh, we haven't done this step yet. And they think, well, we don't have time now, so we'll find out in a couple of weeks whether we have the data we expected to have or not. So this is the thing, the QA pipelines is the bit that we were looking to try and see how we could produce a better way to test your data quality at that stage. So this is a snowplow pipeline. I'm not here to sell snowplow, this could be anyone's pipeline, but this is what we started off with when we were trying to solve this problem. So we have I need to be careful not to move too much so I stay in focus. We have the website here, or the app, or the IoT device with a tracker embedded in it that's sending events over to the collector. The collector puts them in a stream which goes through to another service that validates the event against a schema repository. If the event isn't valid, then it goes through into the bad rows. It then enriches it with information from third parties, or it breaks down some of the things that are delivered from the browser into individual components like the user agent string. This is a simplified diagram. If anything fails at this step, it also goes to bad. So then the valid enriched events go into another stream. They get picked up to the loader and then put into the target. So we can load into BigQuery, Redshift, or Snowflake DB. And then this little set of circles is the data modeling step. So there's quite a lot there to test if you wanted to test whether your tracking strategy, which is the bit that you're doing here, if you want to make sure that your event's going to get over here, that's a lot of distance between those two components to embed into an automated test. And here are some of the problems that we faced. So this pipeline takes minutes to spin up. Not bad, because rewind maybe 2 years ago, it might have taken a couple of weeks to set up a pipeline, but because we put in a lot of automation into the pipeline setup, we can now spin this up in 10 minutes. We have steps here that we don't really need to test. This normally only, so in terms of the tracking strategy, we'll know if it's wrong around this step here. If it fails at enrichment, it's normally because something big happened, like a cloud outage or one of the APIs that we depend on went down. The same story really if it fails at the loader. So really this step here, we don't really need to test if we're just trying to look whether our tracking strategy is in place or not. It also takes minutes for it to get to this point here. Again, impressive, there's a lot happening here. But it can take time for it to get to the point where we can start to assert whether that data was received correctly or not. It's quite tricky to query because we have lots of different places where data could be sat at any point in time. And this is quite costly to run. So it takes a while to spin up. Even scaled down, there's an inherent cost with it. So if you did want to do some automated testing against this, if you had a big team and you wanted them all to have a data pipeline in order to be able to run some automated tests against it, then it's going to rack up your costs. It's going to be pricey. So these are some of the problems we had if we were thinking about doing automated testing around one of our full pipelines. Any questions on the pipeline before I go any further? I'm very aware that's a very quick intro to something that's quite complex. I'll crack on. So the real pivotal moment for us is we built something that we call Snowplow Micro. So Snowplow Micro is the smallest possible version of our technology. And this is the same kind of diagram. So we have your website or your mobile device or your IoT with a tracker embedded, and all we have is the collector and the validation step, and then the validation step talking to a schema repository. Then we've got two REST endpoints, one for good events and one for bad events that sit on this point here. So we don't have any Redshift, BigQuery, or Snowflake. All we have is an in-memory store for the events that are coming through it. So the advantages this gives us is that this set of applications takes seconds to spin up. It takes split seconds for us to know whether an event was going to be valid or not. It's simple to query these two endpoints where we can see exactly which events were collected by the data pipeline. This is in a single executable, so if you have an automated test suite that's being run by something like Travis, if Travis can run your test suite, it can definitely spin up a micro for you as well. And it's minimal cost, so this is just a single executable jar, very low resources, and it would be a negligible cost for all of your test runs to have one of these spun up and torn down just for the duration of that test run. So yeah, this is Snowplow Micro, and this allows us to do something quite cool, which is to use automated tests to start to assert our tracking strategy. So what I have here is a test suite that is going to drive the website. So are you guys familiar with automated testing, where you can write like steps that it goes through? So essentially everything that you would do to test, let's say, a website manually, you can codify it into steps, run through, and then make assertions along the way. So you can say, if I've gone to this page, I should see this thing. If I click this button, this should happen next. So that's what we can start to do, and to drive the website as we would normally, testing that the functionality works, but also at the end of those tests, then query our API endpoints to see whether we sent the events that we expected to send. Everyone with me so far? Any questions? Cool. So I've been playing with a framework called Nightwatch JS, which I started using at Holiday Extras, and I think you guys still use. So Nightwatch, I like it because it's cross-browser. It's easy to extend, with a little caveat that it's easy to extend once you've figured out how, because the documentation is quite poor, but once you've figured it out for yourself, it's simple. And by far the cutest logo. So this is an example Nightwatch test. So the scenario I've got here is I have an e-commerce store. I'm emitting events from it for the data team to use. And this is my test to make sure that the e-commerce store is working as I expect it to. So my test is to add multiple products to the cart. So I've got a page where it's got a product on there. I can select how many of those products I want to put into the cart, click the button, and make sure it's there. So this first line is clicking on a link that's called shirt. It's a close shop. It's going to select the quantity drop down, and it's going to select 2 from there. I want to buy 2 shirts. It's going to click the add to cart button, and then on the next page it's going to assert that that page has in the cart area, it might be a div, in there it has the word shirt. Not the best test in the world, but it fits on the slide, which is why I've used this one to start off with. So if I run this test, if I'm in that product team on the first slide and I run this, my product works, my feature works, I've done my job. But what we haven't done at all here is to assert whether our tracking strategy is right or not. So I don't have any confidence at this point that when I go to my data team in 2 weeks, they're going to be able to answer the question, is my feature working or not? So this is what we started off by doing. So I've built a custom assertion in Nightwatch that allows me to test whether any bad events were sent during the execution of this. So if I have any events that didn't pass the schema validation, so if I had my laptop, I could show you the types of event problems that I had. But let's say I've called the schema the wrong thing, like I had in the first example, or I haven't used the right enum, or my strings are too long, or something like that. I can catch it at this stage. I can catch it when I'm running the test. I can catch it when I'm developing it, and most importantly, I can catch that before it goes out into production. So yeah, that's the first step we got to, and to be honest, if this is the only thing that people started to do with their tracking strategies, is just to check that the events that they're sending were valid, that's a huge start. And then we started going a little bit further. So I've got another function that I've extended Nightwatch in that checks whether there's an event with that property. So going through this process of adding 2 items to the cart, I want to try and assert that I'm going to get 2 of these cart events. Now that's an assumption as an engineer that I've made. 2 products, 2 cart events. And when I run this test, I might actually find that that test fails. I'll just show you what I've got here. So this is saying I want to check that in the events that were received, so there are no bad events, that's good news, but of the good events that were received that match the schema validation, I'm expecting to see 2 events of type cart event. So that's the event, that's where it says type cart event, and then I'm going to expect to find 2 of them. Now, when I hypothetically run this test, I might find that I only found 1, so that is the point at which I go to the data team. So I said, hey, I thought this was going to send 2, but the tests are only showing 1, what should it be? And that's when they can tell me, you know what, you're only supposed to send 1, but actually you're supposed to have 1 event of type cart event, and in the values you're supposed to have a quantity of 2. So that's good. I've learned something from the data team about how we should be setting up the tracking strategy. So I make that change, I run the test, I test that I don't have any bad events, I test that I've got an event, a single cart event, and that has a value of quantity 2 in it. And whilst I'm talking to the data team, they say, hey, don't forget about context. So in Snowplow, we have Snowplow events, we have this concept of a context, which is if you have something like a product entity that's going to be on every event that you fire from a product page, or a customer entity that's going to live for the duration of that user's visit, you can push those into kind of sub-events that are going to get attached onto the main event. So I sit down with my data team and they say, hey, so you've got the main event right, but don't forget to add the context. And this is the story that we hear a lot from our customers, that the context are the things that they struggle to have that assurance that they're going to be attached to the events at the same time, at the right time. So this is checking that there's a context attached to the cart event, which is of type product entity, and within that we've logged that the shirt color, that I put in a shirt and that the color is white. So this is an example of how we can start to test the tracking strategy alongside the feature test. And hopefully this top bit already exists, and all we're doing is decorating it to say, yes, the functionality works, but what about the tracking? So this goes beyond building assurance around the feature you're shipping. So anyone who's writing automated tests already will know that they pay back in perpetuity. They're quite hard to get in place up front, but then anything that you build on top of your platform, then you're always making sure that the old stuff still works. So as you're adding them in, like that test is being tested over and over again. So and also in a larger team where you're working concurrently with other teams, it's really important to have your tests out there just to protect your feature ongoing. And this is like a classic development cycle for teams who are doing data-driven teams who are trying to measure whether their features are having success with their customers as they go. So you go through the development life cycle, everything's fun, everything's great, you get to the end, you desperately try to add some tracking so that you can show that you tried. And then 2 weeks later you come back with that question, how is my feature performing? Should we roll it out? Should we keep it out there? Should we develop it some more? You find out then that your tracking is wrong and you can't answer that question. So you go away, you try and fix it, you come back, it's still wrong. So it's really important that you close that cycle if you want to have a tighter learning loop. So with something, if you did decide to extend your automated feature tests with tests that test your tracking strategy, then it would look something more like this. You define your tracking strategy up front with your data team, and then at the end you hit the button, you watch the test pass, you can have confidence that when you come back in 2 weeks and ask your data team that question, how is our product performing, they're going to have that answer for you. And I think this bit here, define the tracking strategy, is really important to start stitching those teams together. The discussion around what you should be tracking and when happens far too late in the software delivery lifecycle. What you want to be doing is sitting down with your data teams as early as possible and say, well, here's how it's going to work. What would you like us to track if you want to be a truly data-driven business? And in doing that, like it's more than just having that conversation, but you're also starting to draw up a bit of a contract as well, and you're starting to detail how that stuff works. One problem that we have sometimes with our customers is that we spend a lot of time onboarding people into the product, but when that person that we onboarded into it gets the job of a lifetime somewhere else because their data strategies made them grow and they become really successful, how is that next person going to understand like what was agreed, like when should things fire? So it also adds us a really good source of documentation to say that this is our tracking strategy, this is how it works, which I think a lot of teams won't have. And this is showing that I haven't worked with many happy data teams, but I imagine this is something like what they'd say. And it's really about trying to bring those teams together and get to the point where you can have a really productive relationship between your product engineering teams and your data teams. So in the same way that we invest a lot in the linting of our code, in writing unit tests, in building feature tests, we also need to start putting that same care and attention into our tracking, because any like lengthening of the learning cycle, any gaps in data, any distrust in the data just means that the whole process falls down and you end up in the stage where you're just going to ship the product anyway. So in order to be a really data-driven business, I think it's worth the investment, and it is an investment. This stuff wouldn't be easy to add into your testing strategy, but I think it's worth it if you really want to keep moving and keep getting the answers to the questions of how your product's performing. So that's the presentation. If anyone has any questions, I'm happy to take them.